I'll be arguing that some of the key neural circuitry that changed in our lineage, that resulted in us having our kinds of wildly free and imaginative minds, was the circuitry underlying volitional attention and executive control over volitional operations in working memory. But let's first ask, what is attention really? We all know from our own subjective experience what it's like to attend to something, or to get distracted, or to zone out, or daydream. The famous psychologist William James had this to say about attention over 100 years ago. Everyone knows what attention is. It's the taking possession by the mind in clear and vivid form of one out of what seems several simultaneously possible objects or trains of thought. Focalization, concentration of consciousness are of its essence. It implies withdrawal from some things in order to deal effectively with others, and is a condition which has a real opposite in the confused, dazed, scatterbrained state. So, according to William James, attention is the ability to select some inputs and give them deeper processing while ignoring irrelevant inputs. And the opposite of attention is distraction, or maybe zoning out. But let's try to be a little more precise than relying on our subjective intuitions. Psychologists and neuroscientists have historically taken some concept or word from ordinary language usage. This happens quite a bit in the neurosciences. We take some concept and word from ordinary language, such as memory, and then find, when we look at behavioral data and the brain more closely, that there are multiple kinds of memory, each realized in specialized neural circuitry in the brain. This forces us to invent new words or phrases to parse the mind more finely. We come up with new terms such as procedural memory, working memory, episodic memory, short-term memory, long-term memory, semantic memory, iconic memory, and so forth. Something similar has happened with other ordinary concepts and words associated with the mind. Another example is the concept and word intelligence, taken from ordinary language. When we look at the data, it seems that there may be multiple kinds of intelligence realized in different neural circuits. Certainly, we've all met people who have a high emotional or social intelligence who might not be especially good at math, and conversely, most of us have met people who are amazing at math, but who might not be someone you would want to turn to for advice about a love life problem. That's to say, there appear to be multiple types of intelligence. Something similar has also happened with the word morality. Scientists have come to realize that different kinds of processing go into a moral decision. There are neural circuits involved in reasoning, others involved in emotional processing, and yet others involved in visceral responses such as disgust, all of which appear to play a role in our moral reasoning. The same path has been followed by the concept and word attention. We took this word from English and then realized that there are multiple types of attention realized in partially non-overlapping circuits in the brain. Let's summarize three of the main ones. Our first neural circuit involves wakefulness. It's actually realized in dozens of ancient nuclei in the brainstem that project upward to the thalamus and parts of the cortex. Collectively, these brainstem nuclei comprise the so-called ascending reticular activating system shown here. It plays a key role in booting us up in the morning and then also in shutting us down at night. But being awake is not the same as paying attention. Wakefulness might be a necessary condition for wakeful attentiveness, but it is not itself attention. When we are awake, we can be attending either volitionally or non-volitionally. Volitional attention is also known as endogenous attention, whereas non-volitional attention is also known as exogenous attention. Exogenous attention is the kind of attention that makes blinking lights and sudden noises so distracting. They simply grab our attention whether we like it or not. This is why blinking lights, loud clicks, and sudden onsets of most kinds are so distracting for us. Exogenous attention appears to be rooted in our second specialized attentional neural circuit that uses norepinephrine as its main neurotransmitter. This circuit is connected with a structure called the locus ceruleus. It is located in the pons of the brainstem, shown here. Cortically, exogenous attention appears to be closely tied to activation in what is called the ventral attentional network, shown in orange here. It links ventral frontal cortex, or VFC, with another more posterior area called the temporal parietal junction, or TPJ. These areas feed back to perceptual processing areas indicated here as V for visual processing. Exogenous attention is stimulus-driven and not really subject to volitional control. This is not the kind of attention we're mainly concerned about in this course, because this course is about top-down volitional control. The kind of attention that is of interest to us in this course is volitional attention. It appears to be rooted in our third neural circuit that uses the neurotransmitter acetylcholine as its main signaling agent. These cholinergic signals are thought to project, in part, out of a nucleus at the base of the forebrain called the nucleus basalis of Maynard, or the basal forebrain, shown here. They project to various cortical areas, altering the firing properties of neurons. Typically, paying attention and releasing acetylcholine into a synapse results in changes in neural firing dynamics, most commonly an increase in neural firing rates. Endogenous or volitional attention seems closely connected with working memory areas like the dorsolateral prefrontal cortex right about here and the posterior parietal cortex located right about here. Here you can see these areas, which together comprise the so-called dorsal attentional network. The dorsal attentional network is shown in blue here. It links the frontal eye fields, or FEF, with posterior parietal cortex, or more precisely, the intraparietal sulcus, or IPS. Like exogenous attention, top-down endogenous attentional circuitry can feed back to bottom-up processing, again here indicated with a V for visual processing. But before we get into this so-called dorsal attentional network too deeply, let's ask first what attention does at the level of function. What does volitional attention do? It seems to involve capacities that allow us to monitor, select, emphasize, and track some objects over others that are either not so processed or that are actively ignored. And how do we know which objects to attend or keep track of? Typically, we have reasons for attending to this versus that are held in working memory. For example, we might be looking for Waldo in a crowd. It's hard to find Waldo because he's not defined by any unique feature that could just pop out at us. Rather, Waldo is defined by a unique combination of features, each of which is also found on many of the non-Waldo objects. But when we finally do find Waldo, we can keep track of him even if he starts moving around. The late, great Anne Treisman, one of the top attention theorists and experimentalists, had a model of attention that involved many feature maps and one master map of locations that tied or bound all the features across disparate feature maps together into an attended object. For example, inputs from the world, shown at the bottom level here, were broken up like Humpty Dumpty into many separate processing channels or specialized modules for processing the input. These parallel modular processing channels would produce various specialized maps of the goings-on in the world. There might be a specialized map for form, or color, or motion, and so on. These are indicated by the middle layer here. But above them lies the master map of locations. In humans, this master map of locations might be realized in posterior parietal cortex or the intraparietal sulcus. Attention zooms like a spotlight onto one location in the master map of locations, which then binds across all the features represented on all the various feature maps, the corresponding features together. In this sense, she said, attention functions like a feature glue that binds disparate features across disparate feature maps. And this bundle of bound attended features becomes, through attentional binding, an object that can be tracked over time. Anne Treisman's husband, Danny Kahneman, famous for his work in behavioral economics, is also famous in the field of attention for the idea of object files, which builds on Anne Treisman's ideas. To get an intuition for the idea of an object file, think of the beginning of the old TV show Superman. At least when I was a kid, the old black and white Superman show started out with a scene where a man yelled, "It's a bird, it's a plane, it's Superman!"
Yes, it's Superman!
Think about how this unfolded. At first, the man saw a moving object. He started tracking this object with his eyes and opened a kind of file in his working memory listing the features, location, and identity of this object. At first, he identifies or misidentifies the moving object as a bird, then as a plane, then as Superman. Over time, almost everything in the contents of this so-called object file changed. The name changed, the identity changed, the location changed, the features changed as well. The only thing that did not change is the fact that there was a shared object file open in his working memory that kept track of the attributes of this tracked object over time. So an object file is a sort of folder in working memory that updates the attributes or features of an object as it is tracked over time. It permits manipulation of that object in working memory as well. It is the circuitry underlying attentional object files that most centrally led to our kinds of amazing, imaginative, and free minds.